National 5, Mr. Bear Grylls Bulls here for another instalment on National 5 Physics. It's snowing. This is Queen's Park. Beautiful flurry of snow last night, and today I'm going to talk to you about pressure, force and area. Simple equation, P equals F over A. Pressure is this new thing that we're talking about, measured in pascals, and I just want to tell you one example with the snow that is actually a really good example for pressure. Now, when I step into snow, I sink a little bit because the area of my feet is quite small. But if you think about people who are in like snowy climates like the Yukon in Canada, you think, right, what do they use? Sometimes they use like tennis rackets in their shoes or skis or snowboards, and when they do that, they are increasing the area that they are impacting on the snow, which therefore, if you have area on the bottom and you have force on the top, if you divide by a bigger area, you're going to have less pressure. So bigger divided by bigger area, less pressure, which means they're not going to sink into the snow, which means that they can then move in the snow a lot easier. So that's just an example of how we use a kind of, I guess, bigger area to move through the snow better. So Nova's also having a great time in the snow, and I hope you're enjoying the snow wherever you are. And National 5, let's go back and talk a little bit more about this in the PowerPoint, and I'll see you there. National 5, we are here, and I'm going to be talking to you about something new today called properties of matter. Now, I just realized that I did this a week before it's actually being launched. So you will have had snow, but you probably don't have any snow at the moment. So I do apologize, but I hope you had a great time in the snow and did a whole bunch of stuff like sledging and snowballs and all that under lockdown restrictions. But I trust you did. Now, Lockdown Sessions 2.0, properties of matter, a new topic today. So this is stuff that you have not done in class, no one has done in class, and we're going to be going through a whole bunch of this stuff that may or may not feature in the prelim, but is worth definitely working through the material that I post on this each week, okay? Now, as always, subscribe, like, and share. I'm probably going to have to stop actually saying that because it's probably going to get a little bit ridiculous how many times we're going to have lessons, but you know the script, and as long as you know the message, that's a good thing. Right, we're going to first of all talk about pressure, force, and area. I obviously chatted to you about this in the snow a little bit, but let's actually talk about what this means. So, our learning intention today is to define the pressure and cover the equation linking it to force and area. Success criteria to successfully complete PFA questions, which you will hopefully do today, and to also understand situations in which altering surface area would be beneficial in terms of reducing pressure. Alright? Now, let's look at some examples. Alright? So if you've ever had a drawing pin, alright, there's a reason why one side is flat. So if you press in a drawing pin, in the flat side, there's a bigger area. Now, why do we want to press on something that has a bigger area? Well, a bigger area spreads out the force, which means that there's less pressure on our finger. If we were to put a pin in the opposite way, that just wouldn't work because the pin would then go into us, because the very small area of a needle is so small that there's an intense amount of pressure. Alright, so that's why things that are really sharp have a lot of, if you have the same force with something that is not as sharp, it's all about the pressure that has on whatever it's going into. Alright, so things that have a small area will often have a very high pressure when pressed in with the same force as any other object would be. Or look at heels or slippers. Obviously heels, and if you've ever watched any dramas or like CSI dramas or murder dramas, then people can get killed with heels because, again, it's a sharp, small area object that can create a lot of pressure as it moves into something with the same force, for example, that we would have if we were to press slippers onto someone. It would not nearly be as damaging. Alright, don't think anyone has killed anyone with slippers before. But, so that's some examples. Other ones, how would you use a ladder to help cross a frozen pond? Well, if you have enjoyed the icy weather, I have been walking in Queen's Park recently, and there has been some people skating on the ice, but if someone had fallen through and the ice was pretty precarious, what you would have to do is you'd have to spread your body or use a ladder or have some sort of larger area so that your force is spread out, so there's not enough pressure on the ice, which means that you would fall through. You're trying to minimize or maximize, I should say, the area. So that means that you can pull someone from a frozen pond and without you falling in yourself. Okay, so it's all about pressure, force, and particularly area when it comes to this equation. Now, if you're just sitting at your desk listening to this, hold a pencil between two fingers. You'll obviously then feel that one end is a little bit flatter or has a larger area than the other end if it's a sharp pencil or a pen. And again, it's the same idea as before. Okay, but think about this wee question. By Newton's first law, the forces applied by each finger must be balanced as the pencil is stationary. But why does each finger feel different? Okay, so pressure has something to do with the force and the area as we've been talking about. So have a wee think of that in your own time. All right. Now, the equation here: pressure equals force divided by area. I talked about that when I was in Queen's Park with Nova. And the units of pressure are newtons per meter squared, or, and this is the one that we prefer, pascals, which is P, capital P, small a. So always use pascals when you are answering in pressure. Okay. Now we're going to go through some examples, and I've actually just written the examples down. So what I almost encourage you to do is, after I've talked about it, pause the video, answer the question yourself, and then see if your answers correlate to the answers I have in the next slide. Okay, so example 1, a box exerts a force of 30 newtons over a surface area of 0.25 meters squared. Now, can I just also point out that we must always have area in meters squared, not centimeters squared, not millimeters squared, meters squared. So please make sure that you're doing meters squared. So this is already in meters squared. Calculate the pressure. Right, pause the video. And once you've done that, start up again and see if you got the answer right. Okay, so if you paused it, excellent. If you've not and you're just waiting for me to go on, then shame on you. But this is what I got. P equals F over A. 30 divided by 0.25, 120 pascals PA. Okay, very easy, very simple equation. Something that should not cause you any issues. Example 2 says, a 0.5 kilogram steel cylinder of radius 10 centimeters is placed on a bench as shown. Calculate the pressure exerted. Now that diagram looks pretty shocking, to be honest with you. So just look at the example and see if you can answer the question. Now I'm going to give you a wee bit longer time. Well, you're just going to have to pause it for longer. This is quite a tricky one. So if you don't get this one, I will talk you through it, but give it our best shot now. Okay, if you paused it, well done, and if not, then shame on you. But this is it here. What do we have to do first of all? Well, we have to find the area. It's a cylinder. Keyword is a cylinder, which means it has a circle. So if it has a circle, and it's the circle part that's going to be acting on the block, we need to do A equals pi r squared. And pi r squared is just the area of a circle, and if we do that, we get 0.031 meters squared. Okay, making sure that the radius is not in centimeters, it's in meters, so 0.1 squared. We also need to find the force. The force is in this way is just going to be the weight that's acting down the way. So I'm just going to use W equals mg, okay, which is 0.5 times 9.8, which gives me 4.9. So I put those two things into the equation over here, all right, and it's P equals F over A, 4.9 divided by that answer, and I get 156 pascals, okay. Now, please just, if you need to go back, rewind it, have a look at how I've done that, but it's just finding the area, finding the weight, because that's what's being the force that's being pulled down, and then use that equation. So the next one, example 3, a 3 kilogram rectangular block of dimensions 10 times 12 times 5 centimeters is placed on a surface. What is the maximum pressure that the surface could experience from the block? Okay, so quick hint before you do this one, after you've paused it. Maximum pressure must mean the smallest area. Remember what I've talked about? When instead of having, like, remember a pin, the small area has the maximum pressure. So find the smallest area from the rectangular block. What side, what area is going to be one that's going to provide the maximum pressure? Okay, so pause the video and then I'll talk about it in 5 seconds. Okay, Well done. So this is what I've done. Maximum pressure equals the smallest area. The smallest area, remember, in meters, is going to be 0.1 times 0.05. Okay, that's going to be the smallest area. I'm just taking the two smallest numbers, timesing them together, because that's how you find the area of that side. So 0.005, I do the same as before, it's just the weight down the way, W equals mg, and that's 3 times 9.8, put them in, 29.4 divided by 0.05, or 005 is 5,880 pascals. Okay, so that should be the answer for that one. Now, last one. An aircraft cruises at an altitude of which the external air pressure is 0.4 times 10 to the 5 pascals. The air pressure inside the aircraft cabin is maintained at 1 times 10 to the 5 pascals. The area of the cabin door is 2 meters squared. So we've already got meters squared, that's excellent. But what is the outward force on the door due to the pressure difference? Right, so see if you can try this one. Pressure difference is the key word there. I'm going to give you 5 seconds and before I go over it. Okay, so if you've managed to pause each one and you've got them so all right, this is the last one. So difference in pressure between outside and inside is 0.6 times 10 to the 5 pascals. I just put that into the equation. It's now rearranged though for F equals PA, and that's just going to be times by 2, gives me 1.2 times 10 to the power of 5 newtons. Now just a wee side note, often pascals comes in these large numbers, so you have to be ready to use that in your calculator. So the equation there again, P equals F over A. Alright, very easy equation. We've done equations like this before. It should not be tricky. The questions that I'm giving you are not tricky, but it just gives you a chance to really go through it. The hardest thing is finding out the area, finding out the weight of an object, and then using P equals F over A. That's as hard as it will get. Making sure that everything is in meters squared. Okay, so I feel that we've done both learning intention and the success criteria. Again, National 5, well done for tuning in. Start the questions and we'll see how you get going. But I hope you enjoyed the video. I hope you enjoyed little Nova, who probably stole the show with her running and sliding. And guys, I do hope you are doing okay and that you're able to get through this lockdown and keep yourselves busy and occupied with the schoolwork that we've got going. Guys, all the best, and I'll see you again on Thursday.